talking about a new concept. We developed first the concept of interfacial tension in our previous class, and now we're going to talk about wettability. When we were talking about interfacial tension, we were talking the relationship between a fluid and another fluid, a liquid and a gas, a liquid and another liquid. So we needed two fluids to relate interfacial tension, being one of them liquid, of course. Well, now we're going to talk about wettability, as is here. It is here. And when we're talking about wettability, we have a new concept here. Instead of only two fluids, one liquid and another gas or liquid, we have two fluids and a surface in contact with these two fluids. It has to be in contact with the two fluids to have wettability. So we're going to develop this concept. Wettability is what I showed you in our first class when we saw the shape of the droplets. If we take a close look at the shape of this droplet here, you see? And we look, that's the surface here. And this is the angle. Get from the very corner here, and you see the tangent, we have the angle alpha, the angle that the droplets form. Okay, so we have this fluid here, which is a gas, G. We have this fluid here, which is a liquid, L. And we have the surface, S, here. We have three different materials in contact with each other. And this is called the contact angle. And by definition, contact angle, it's always measured within the denser fluid. So we're taking a look at this. Contact angle is within the denser fluid. And there's a sentence that you have to keep in mind. L is a wetting fluid of the surface S with respect to fluid G. That's how we understand. It's a sentence that connects the three materials. L is a wetting fluid of the surface S with respect to fluid G. Well, take a look at this other shape here. Now we have a different contact angle, still measured within the denser fluid, the liquid L. Gas, surface, liquid. Okay? And then we have this different contact angle, which is higher than 90 degrees. Okay? So contact angle, again, it's always within the denser fluid. And now I will say that L is a non-wetting fluid of the surface S with respect to fluid G. Well, if the contact angle then is smaller than 90 degrees, we say that a liquid is, the denser liquid is a wetting fluid with respect to the other fluid. Okay? So if the angle is larger than 90 degrees, we will say then that the fluid, the denser fluid, is non-wetting of the surface S with respect to the other fluid G. Okay? Well, this sentence is very important, and you have to see, as it's written here, that a wetting and a non-wetting phase will coexist. If one fluid is wetting, the other has to be non-wetting. Let's say water and air. If water is wetting of a given surface with respect to air, then air is non-wetting of the same surface with respect to water. Okay? Well, if we pick oil in the same surface, and oil is non-wetting of a given surface with respect to air, so air would be wetting of a surface with respect to oil. Okay? So we can always look for the contact angle to define which fluid is wetting and which fluid is non-wetting with respect to another. Well, a particular point when the contact angle is zero. The fluid is so wetting that the contact angle is zero, so it is called perfectly wetting fluid. That's a particular situation that we may find in a field. Actually, for aquifers, we consider water as being perfectly wetting with respect to the surface of the grains of the porous medium. Okay? That's always what we have. Okay? So this is the concept of wettability. Now we're going to show some of the situation. Look at that. Look at this insect. It looks like it's, actually it is, the insect is walking on top of the water. Why? Because the material of its feet is non-wetting. It depresses the surface, and of course it is not heavy enough so that it would sink. But that's wettability that we see here. Look at that. We see the liquid that is touching this rod here. If the liquid is touching the rod and it's moving upwards, that's because the liquid is wetting with respect to this rod. Okay? Another situation. Look, this coin, it's apparently, and actually, it is pushing this fluid. It is pushing the fluid. You see that the fluid is not covering the surface of the coin. So we can clearly say that the coin, it's non-wetting. Right? The liquid is the liquid is non-wetting with respect to air for this coin. Okay? That's very nice picture. Look at that. That's the meniscus. We've seen meniscus in a lab, at home, in several places. Well, if the meniscus is in this situation, we see that this liquid, the liquid that is in the bottom part, tends to go up. The fluid tends to move upwards. And as it tends to move upwards, that's because it's trying to wet the surface of this fluid. So it is a wetting fluid. Look at that situation, how nice it is. We have one that is concave and another that is convex, depending on where you're watching, of course. But look at that. Here we have air and this fluid, and here we have another fluid in contact with this one here. You see, this fluid here is wetting fluid of the surface of the glass with respect of this other fluid here. And here, this fluid, the intermediate fluid, is also wetting of the tube with respect of the fluid that is above, which is air in this case. Okay? That's a very nice understanding of wettability. We have both situations in a single picture, and I hope you understand. What I want you to take a close look is watching that closely and understanding what happened. Thank you.